Welcome to the third day of the International Conference on Energy and AI. So in the past 2 days, we have a really great lineup of talks focusing on the energy materials, energy devices, and how we can use AI to improve the technologies or to improve the knowledge understanding. So today we're talking slightly big things. So we're focused on the AI and energy systems. So today with us, we have Professor Markus Kraft, Professor Raffaella Ocone, and we will also have Dr. Zamel who will join us for the panel discussion. My name is Xuan. I'm from Loughborough University. So without further ado, maybe we can start the first presentation, which is from Professor Markus Kraft. So let me just briefly introduce Markus while he can upload his slides or presentations. Markus is personally one of my favorite researchers in the field of energy and AI. I follow almost every piece of his recent research because they're always so pioneering and inspiring. So he's a professor in the Department of Chemical Engineering and Biotechnology at Cambridge University, and also the director of the Singapore-Cambridge Create Research Center. So he split his time between Cambridge and Singapore. He's the same as me, a chemical engineer by training, and has made significant contribution in the more traditional chemical engineering areas such as engines, combustions, and other carbon or emission reduction technologies. But recently, he has been pioneering the development of AI digital solutions to solving the chemical engineering or energy problems. He has been pioneering the cyber physical systems employing knowledge graphs with the aim to build large-scale cross-domain applications that help reduce energy consumptions and emissions. Markus is an editorial board member of our Energy and AI journal and has contributed to one of the most cited paper in this new journal about the power system ontology for cross-domain interactions in the eco-industrial park. I think based on that, today he will further extend the concept and talk about a dynamic knowledge graph approach to digital twin. So without further ado, may I hand over to you, Markus, for your presentation.
Yeah, thank you, Jin. Hello out there, whoever there is, So I'm talking to you despite my background picture from Cambridge. I hope you can see my talk. Jin, can you see everything all right?
No, I don't see your talk. So
okay.
I cannot see your screen.
That I'm glad I asked. Let me just share my screen. Let me help. Just a second. Okay, share screen. Okay. Can you see it now?
Yeah, it's coming. Yep, I can see it now.
Okay, that's great. So, okay, so let me just say that this work has been done by many people. So it's already been told that I'm in CARES, the Cambridge Research Center in Singapore, but there's also a company called CMCL, Computation Modeling Cambridge. I'm involved in this company. My research group, Computational Modeling at the University of Cambridge, and this little symbol represents the knowledge graph. Title of my talk is A Dynamic Knowledge Graph Approach to Digital Twins, or the Universal Digital Twin. What does it mean? So the context of this talk is all about Industry 4.0. This is the stage of industrial evolution we are in at the moment. The keywords here are Internet of Things, cyber physical systems, and Internet of Services. So what does it actually mean? Okay, so what's happening right now, we go from digitization to digitalization. Okay, so in the Internet of Things, we have interconnecting numerous devices and sensors. So that include maybe smart devices and ubiquitous computing within the device. In cyber-physical systems, we would say we'd have a higher level of integration between physical and computational elements. Here, it's the first time where we see the cloud, and oops, that was a bit too fast. And the whole system is deeply intertwined. And then in Internet of Services, on top of this cloud data, we do have services. They are supposed to integrate and coordinate the services in a heterogeneous environment, and it's mainly done in the cloud. Okay. However, there are problems with that approach. Okay, and the key word here is low interoperability. Okay, and this is mainly because there are so many different devices. They have different protocols. There is ambiguity in the data. Some people may use the same words. And of course, because of that, we have high friction, and it is difficult to integrate and coordinate data. So the key here is heterogeneous devices, okay, and ambiguity, lack of context, okay. The individual pieces of technology do not really know what they are, okay, and this is where knowledge graphs come in. Okay, just a quick reminder of what knowledge graphs do. First of all, it's important to prove to you that it's a truly modern, fashionable word to say. Okay, if you go to the Gartner Hype Cycle for emerging technologies, you see in 2019, knowledge graphs were just about at the innovation trigger stage, and these are the expectations, very high expectations. And then just 1 year later, we are already in the trough of disillusionment, okay, and so soon to be on the plateau of productivity in just 1 year, okay, and that means that this technology is exploding at the moment. So what is it? Okay, the first time you have come into contact with knowledge graphs, of course, with the Barack Obama case, with Google. When you Google Barack Obama, then you get this information box, okay, and that is normally shown as an example of knowledge graph that's behind Google. And what does it mean? They represent the information in a graph, in a directed graph, and you see instances like Barack Obama is married to Michelle Obama. Michelle Obama lives in the United States. Hawaii is located in the United States. And just like we have represented this small bit here by a graph, we can do anything else. So it is not restricted to any particular application field. It can contain anything that you can express as a concept in graph form, which is pretty much anything you can think of. Right, and that has led to something that we call the World Avatar Project. It's a world model, a dynamic world model. Okay, and it's a general purpose and all-encompassing data storage and modeling framework. It contains concepts and data that describe the real world and are operated on that. So here you see the dynamic knowledge graph. So this is distributed down here. These are the ontological representations. So these are the definitions of the different domains, like politicians or electrical engineering or power systems or whatever it is. Okay. This is linked data because it's all in a graph. It contains an ecosystem of agents. Okay. Now you could sort of see the green area as being your hard disk on the computer, although this doesn't exist anymore. It tells you how old I am. Okay. But and the red bit is sort of the memory. Okay. So these agents exist here as an instance. There is an agent ontology, and in the memory, these agents are operating. Okay, so there are input agents. Okay, there are agents that are communicating with one another, form a composite agents, there are discovery agents to build these composite agents, and there are atomic agents that can, for example, do output and input. Okay, so we have this whole ecosystem, and as a result, this is unambiguous. It's connected, scalable, distributed, accessible, multi-domain, interoperable, and it's evolving in time. Okay, it sounds too good to be true. Unfortunately, the whole thing doesn't exist yet, but this is our main project, to build it up together with the community. And what I want to do now is I want to show you a number of use cases. If you go to our former website, you see knowledge graph, a lot of preprints, and we have covered in the past electrical and chemistry coupling, a virtual sensor. We're developing a UK national twin. I will talk later about combined heat and power. We can represent chemistry. I will now say something about city master planning and representing of cities. We have a Marie chatbot that allows natural language query to the knowledge graph. I will also say something about the building management system and the ability of the knowledge graph to do parallel world scenarios. Now, what you see here is the result of an agent that allows you to take building information that is expressed in city GML format, which is one of the widely used building representation standards, and upload it into the knowledge graph. Here you see 22,700 buildings, and this is actually Berlin Charlottenburg, and here you see the Olympia Stadium. And these buildings are all in the knowledge graph. They are in the so-called LOD2 format. This is level of details 2, and just demonstrates that we can include large amounts of data. So you can then zoom in, and then you see how these buildings look like. Question is, what do you do with it? Okay, so this, what you see here, this is now a LOD4 city GML model of a HDB block in Singapore, which we are now currently trying to get into the knowledge graph, and we can focus on each individual apartment. Okay, so we have agents in the world avatar, and one of the agents is, for example, able to extract object pairs that meet specific distance constraints. For example, at unit types, I want to find all shops within a 1 kilometer radius, or agent 2 means I retrieve city objects, average, minimum, maximum distance to other city objects, for example. What you see on the left-hand side, these are Blazecraft interfaces. So you can, at the moment, formulate what is called Sparkle queries by hand to extract this information. Of course, we have agents that produce these Sparkle queries and are then capable of automatically finding this information in the knowledge graph. Right, so now we're moving to the CARES lab in Singapore. Okay, so we have what you see here, that is the laboratory I work in Singapore. That is U-Town, over there is NUS, and we are now focusing on that top level in this building. It's called the research building, and here we have a detailed floor plan, including sensors and their relative positions. So in the world avatar, we represent and simulate and receive data from each of these real entities. And these sensors record time series data, and we just plot it out here. In this case, for a variable air volume unit and its component. So the world avatar, now this is the part of the knowledge graph you see, sort of is the digital twin of the lab with room location, sensors, and key variables. The makeup air unit agent is using the real-time ambient humidity data, and that's what you see here. It's not very interesting because in Singapore, humidity is always high, okay? This is why this is a flat line. And then we have the temperature data from the lab. Here is the temperature data to optimize total cooling duty required and also circulate the cooling water. Okay, so this is an example how this knowledge graph is not just a simulation, but is actually part that connects to the real world. Okay, almost as if it was the brain of the world. Okay, it controls it, it understands what it is, and it can actuate. Right. So this was an example of one building. Okay, and now I show you something a bit more general. Okay, so this is actually the district heating problem. Here we have to recognize that district heating is expected to play an essential role in the cost-effective decarbonization. Okay, why is this the case? Okay, it is the case because we can use industrial waste heat. We can have benefit from the economy of scale, and of course we can do electricity cogeneration. And on the right side, you see in this graphic, this is CO2 output, and these are district heat systems in different cities, and these are single city ratios of primary resource factors, basically a ratio between the used heat versus the used energy versus the actually used energy, the effective usage. Okay, and basically bottom line here is that the lower you are in this corner, the more effective you are. Okay, that means for one unit oil, you get a higher degree of utility. So this is why people want to look at district heat systems. However, we need more flexible operation in future because we will have more renewable energy, and there is an increasing importance of smart integration in mixed energy systems like sector coupling and prosumer trading. These are the two keywords. And if you look at this graph, you can see that over the last few years, the share of renewable energy has increased a lot. For example, in Lithuania, has increased enormously. Also in Germany, it has increased a little bit. That means that a district heating system needs in future to be quite flexible. Okay. Now, last year when I was stuck in Pirmasens in my hometown, I was actually talking to the utility provider called Stadtwerke Pirmasens, and they have a district heating system of several hundred residential customers. There are multiple industrial customers, hospitals, schools, and multiple degrees of freedom to satisfy customer demand. So there are some boilers, okay? There is combined heat and power gas turbine, okay? There is the energy from waste plant, municipal waste incinerator. We have, of course, a distribution network, some heat storage, and the consumers. And the question here is, how do you operate this to get the best performance, okay? And at the moment, okay, this is done at a static level, okay? So the evaluation of the most beneficial high-level operation set point is only done several times per year. It's discontinuous evaluation of potential profitable gas turbine operation, and largely driven by heuristics and personal experience. So it's also a problem to pass this on to other people, how to do this, okay? Now, we have implemented the whole thing in the knowledge graph using heat load forecasting agents, and for that, we've been using some machine learning algorithms. And what you see here is the historical time series and the forecast, and this is sort of the error. And then with that forecast, we were able to do model predictive control approach and did some optimized heat generation. Here you see the gas turbine, Kessel is the boiler, and this is the heat, the municipal waste incinerator power station. And you can see that compared with the 2018 actually historical generation, the knowledge graph had a slightly different way of using this. You can also see that these large verticals here represent the gas turbine to be switched on. And so just by using the gas turbines less, because there is a cost associating with that switch, we were able to actually reduce the overall cost by about 26% per annum, just by using this fully digitalized knowledge graph digitalization approach. Right. Okay. So maybe it's not quite the end. So at the very end of my talk, I'd like to do a little bit of advertisement for our book that's coming out very soon this summer, Intelligent Decarbonization. It contains a number of very good articles in conjunction with interviews. For example, Paul Monk, the Chief Scientific Advisor of the Department of Business, Energy, Industrial Strategy of the UK, or Professor Ho Teck Hua, who is the chair of AI Singapore, and many others. So please watch the websites and the news. You'll see many interesting events. Also very soon in August, a CARE seminar where everybody who is interested in this can take part. And with that, I would like to stop my talk. And if you have questions, I'm more than happy to answer those. Thank you.
Thank you very much, Markus. It's really an inspiring talk and also very good time control as well. So we do have several questions from the audience. So because of time, probably I cannot take all of the questions. But one question is to you, Markus. How, according to you, in terms of using search engines, we are able to tell differences between the truth or fake news and to protect ourselves from the fake and uncredible informations? I think here it's more about when you use a knowledge graph, how can you tell that which information is true or which is fake to be included in your ontology? So are there any insights from you on these aspects?
Well, the knowledge graph is no different to the real world. Okay, so how do you tell whether something is fake news or not? You do it by comparing it to other pieces of information. You do consistency checks. And this is something you can automate in a knowledge graph. Okay, this is something where, you know, a human finds it very difficult. We have to take this information and trust it, because we are not able to get the data that either supports or falsifies this piece of information. But if you are an agent in a knowledge graph, of course, you can Google within the knowledge graph. You can basically find an agent that searches that information and check it. So if what we call the base word, the word model, is accurate enough, it'll be relatively easy to find fake news.
Okay, thank you. So there's another question with your various digital twins. Which elements are most difficult to accurately predict? It may be like certain things like human behaviors are more difficult to predict, or is it the case, or what other elements?
That's a good question, but I think this is independent of the knowledge graph. What is easier or difficult to predict? Okay, now I don't know whether you are using Google Timeline and you look at what you do. Google is actually quite good at predicting what you do in the next hour or the next half an hour. But I think the closer you go into the future, I mean, like the less distant, then the easier it is to predict, okay, because all the nonlinear effects will basically make it impossible to predict, even if you have models that are trained on you know, even on lots and lots of data. True prediction, in my view, is not possible in principle, not possible. The only way to predict is to actually let it happen. Yeah, that's what I think.
Yeah, thank you very much, Markus, for your presentation again. So we will move on to the next speaker, Professor Raffaella Conley. So Raffaella is a professor of chemical engineering at Heriot-Watt University. I have had the fortunate to work with Raffaella there for 4 years before I moved to my current position in Loughborough. And I also have a fortunate to work together with Raffaella in establishing the Energy and the AI Journal together with Professor Craig Zhao as a founding editor. So as you can imagine, because of her scientific excellence and great contribution to the community, Raffaella carries many shiny titles and awards, such as the Fellow of the Royal Academy of Engineering and being appointed as OBE in the 2019 New Year's Honor. But among so many titles, Raffaella, you know, what I like most is the less formal one, which is the one you put in your Twitter introduction, the first female professor in chemical engineering in the UK. So Raffaella is a true leader in promoting the diversity and the inclusion in the engineering field, and also leading the development of ethics in engineering, the responsible research and the innovation, etc. So over the years, she has been inspiring, mentoring, and supporting many junior engineers and researchers like myself and many others, especially those in minority or disadvantaged background. So very related to that, today she is going to talk about the engineering equitable research and innovation. So without further ado, Raffaella, may I hand over to you?
Thank you, Jean, for this incredibly nice presentation, which I don't know if I fully deserve. I just would like to check if you can see my screen.
Yes, I can see your screen.
So is it fine? Is it good?
Yeah.
Okay. Oops. Right. So thank you very much to the organizers for the opportunity to be here with you today. Well, actually, to be honest with you, I would have hoped to be in person with you today. I was also very fortunate to be at the very first conference of this series in China in 2020, January 2020. And I thought to put some nice pictures there, and you can recognize our previous speaker today. You can recognize Jean from the pictures. I thought it was a nice thing to think that, you know, it was only 2020, but to me looks like ages ago. Anyway, so I want to start from a slide that actually I did use when I gave a presentation at that conference. And I said that these are the challenge that we will have in the third decade of the 21st century. And as you can see, this list now looks a little bit like incomplete. And in fact, I mean, today, probably if I had to write this again, I would put pandemic at the very top of this. And this is our challenge now. But overall, I would say that we have to move forward. We have to go to a world which is going to be different, I suppose, from what we had so far. And then this is why I think that this world at the end has to be a little bit more inclusive than it actually has been so far. And this has to be really very much based on equitable energy for everybody, but also very diverse and very inclusive, so open and accessible to everybody. Now, everybody that works in artificial intelligence, of course, is aware that the most important ingredient for developing algorithms, but also for training our machines, is having data. And then what we do, we use the data from the past so that we can train the machine, and then we can have the prediction for the future if possible. Now, this is a picture. I don't know if you can spot me in that picture, but this is around 1990. I was a graduate student at Princeton at the time, and this is my graduate school class at the time. And what I want to draw the attention on is these are the academic stuff. As you can see, although within the cohort, there were many people from different countries, different ethnic backgrounds, quite a large number of people, well, quite a large number of women, well, not really large number, but a good percentage of women. Within the academic staff, there was not a single woman. Another thing that I would like also to draw attention to is the time in the morning, 7:30. Then 1995 is when I moved to the UK. And why 1995 is important? It's important because I believe it was a very important year for the development of equality, diversity, and inclusion. In fact, I mean, there was this very important conference, the fourth UN World Conference on Women. And this conference, governments from all around the world agreed a comprehensive plan to achieve global legal equality. And that was known as Beijing Platform for Action. And it was in Beijing, and more than 25 years have passed since then. And where are we today? Well, this is a report that came out last year. And today, 53% of bachelor and master's graduate are women. When you move towards PhDs, it goes down to 43%. And then when you go to researchers, it's only 28%. So first thing to consider, there is definitely something which is going on, which we are losing skills, we are losing people as we progress towards research. And indeed, in a computer science, for instance, there are relatively more women, and in some countries there is even a parity between women and men in the life science, for instance. In computer science and engineering, women are really behind. And the thing which is also extremely relevant, and again, I would like really to draw attention to this point, is that the difference between the low number in women is very high in very high income countries. So that's something which clearly doesn't work very well. And there are, of course, inter-regional variations, but these are the data that we have available at the moment. There are regions like, for instance, the Philippines and Thailand, where it's about 52%, which is very good. And but then it goes down to only one woman in 3 researchers when you go to Indonesia or Singapore, for instance. And the Republic of Korea and Japan, ironically, these are countries where IT are very well developed. The numbers go down to 18% and 15%. So women in engineering are constantly underrepresented. And this is what we have. Again, very low numbers. No matter where you go and what you can observe. Another very interesting point, and perhaps we can discuss this later, why is that? In some developing countries, women have higher percentages of women than in the developed countries. And this is, again, another thing which is very worth to understand and probably to take some examples from the developing countries. Now, I don't know if I was now in an audience and I was like, who is this lady? I was going to ask, and I was going to look, and somebody probably could raise the hand and say who this lady was. Unfortunately, you cannot answer to my question, and then I will tell you. This is Ada Lovelace, and she was a mathematician. She was the first one to recognize that a computer can have applications beyond pure calculations. And in fact, she published the first algorithm, which was intended to carry out calculations in that machine. Now, she's also considered to be the first computer programmer. Ironically, today, there are not many women programmers in this area. These are data from the UK, and I apologize for being UK-centric, but this is what I could get very easily. So in the UK, 47% of the overall UK workforce is female. 17% of the tech sector is female, and goes down to 16% when of engineering and computer science degree when they are conferred to women. But this is the most important thing, and you will understand later why I put this in bold. It's the number of programmers and developers of algorithms that is very low. And now it's just gender, which is easy, very easy to check. But I'm sure that the same data can be checked for other diversity, like, for instance, ethnicity. It can check for sexual orientations. It can check for anything else. And that number is consistently low, which means that these algorithms carry a bias, because these algorithms are not developed by the population like is represented in the real society. So this is another point which, again, it's very important to notice. However, I don't want to be very negative. There are some good, not very good, but good outcomes. And in fact, I mean, you can see that in Malaysia, numbers of women in information technology is high, and India is doing also very well in engineering. However, computer science systematically goes down when you look even at these countries, and more importantly, it goes down if you are in a high income countries. Now, I apologize, this is in Italian. It's an Italian newspaper. And in June 2020, essentially what it says there is that as soon as we went into lockdown and we started to work remotely, 37,000 women left their job. And that was essentially because they had to reconcile looking after their children, their parents, and to take care of the house. So many women left their job because of the lockdown. And there is a piece of good news. The month after this, when if you remember, numbers in July 2020 in Italy started to go dramatically down. The situation was very good during the summer. New jobs were created, and 80,000 new jobs went to women, over a total of 85,000 new jobs. And this is an incredible result. So good that I was a little bit skeptical. So I went and I investigated what was going on. Essentially, these are very low paid part-time jobs. So again, there is not anything which is putting in place what it should really be. In other words, that women should have good good paid jobs. These jobs are jobs that men didn't want, and that is why the numbers went so much high. And then, of course, there are many other reports. You can see the Royal Academy of Engineering looked at the gap that there is between what women get and men get for the same kind of work. So if they do the same job, women get systematically less. And also there are much less women in high position jobs. And again, this is something to reflect on. Now, if we want to really, and we want to make sure that the sustainable development goals are what will drive our equitable future, we have, I think, to look at these goals more like challenges. Because if you go in an English dictionary, there is a difference between challenge and goal. And I think that for us, it has to be a challenge, because this is something very difficult, which requires very great effort and determinations. And I think that in order to change what it's really the current situation, we need really a lot of determinations, and we have to really work extremely hard. Now, what I want to say here is that although I have very much spoken about women, I don't think that the problem is just about gender. And I think that diversity and inclusion should really be embedded in everything that we do in order to promote and to make the sustainable development goals being a reality. Now, it is a fact that, for instance, of course, I mean, there is there are goals that are specifically about inequality, diversity, and inclusion, but all of them included in a way or in another. In fact, if you look, for instance, at the one about climate change or energy, climate action is called women and low-income groups are probably the ones that don't make the decisions, but they will be the first ones to suffer for climate emergency. Because if there is a very bad drought or a very bad flooding, and this is going to be in a low-income countries with people that cannot afford to live in good houses, they are the ones that are going to be hit first. Switching to energy, and of course the things are related, because a better future should guarantee good energy, renewable energy, and energy that everybody can have access to. I did a final year research project this year with Nicole, one of my students who graduated in June. And we looked at the decarbonizing the energy sector, but we look it from a different point of view, not just from the technical point of view, but also from the social point of view. And Nicole ran a very interesting survey. And then I don't have the time to speak to you about the survey now, but that's another presentation. But I think that I would like really to look to show you that things that we have to take into considerations for an equitable technology is of course looking at how we can distribute justice, how can we be accountable and transparent, how can we responsible, how can we make sure that the future generations are not going to suffer. And there are results that really are striking sometimes. And then, for instance, this is during the pandemic, somebody says decarbonization is important, but not urgent. And then also there were comments about policies which are required, but everybody says more or less that, but implementing the changes is really difficult. And of course, I mean, when I look into this, I think that what we have to start to do, we have to start to change upstream. We have to start to look also at the way we create skills, at the way we create we educate the next generation and probably the people that will contribute technology and education for the future. Now, in that survey, and this is really something that I couldn't believe myself when I saw it, one academic teacher, thankfully this was an anonymous survey, one academic teacher said, "I don't believe in the climate crisis." And I don't want to enter into any discussion about that, but clearly I think that sometimes we still observe a disconnect between what we are teaching and what the skills that are required should be. Now, this is my exam. Speaking of teaching, this is my exam this year. And I was extremely proud of this exam. And I'll tell you why. I was proud because these are results that actually one of my postdoc got in our lab. And since I was really struggling to put together an exam, which was taken at home, and people could not find already some results on the web, I said, what can I give to them that really can make me certain that they are really working and understanding what a Moore circle is? So I took this data from our labs, put it in an exam, and I was so proud that I even tweeted that, okay? Right, so the time goes by, Nicole graduates, and she meets with me, we have a chat, I like to speak to my past students. And of course, I mean, it doesn't matter if you are a past student and you have just graduated, but the exam always comes into discussion at one point. So I was curious and I said, Nicole, how was the exam? What was the feedback from other students? And Nicole said, well, it was a good exam, I think, but we thought it was not very fair. At that point, I was extremely surprised. And of course, I mean, I wanted to erase my Twitter. I said, why was not fair? And then she said, because you didn't realize, and let me go back, it's green, red, and blue, and they are colorblind people in the class. So at that point, I stopped and I realized we all have bias. We all do things that we are not supposed to do because essentially we cannot imagine what the reality is for people that are different from us. And this is why the message is, this is why going back to the fact that IT should have programmers that include people that are probably colorblind, to make sure that that programs take into consideration some issues that somebody like me is not aware of. So it seems that so far I have given you only problems, no solutions. Well, I think that things are moving and things are well, a little bit better than what they look. The Royal Academy of Engineering has done a lot of work in this area, and surveys have shown that it's not just a gender gap, but of course, I mean, it's matter of having BAME people included, people with different sexual orientations, disabled people, different ages. So it's really extremely important that all those are included in our considerations. And this is what it comes out, what is the percentages of people surveyed by the Royal Academy of Engineering that declare that they are under that different groups of people. And there is a lot of work, like I said, and more importantly, the development of a framework that gives the opportunity to organizations to measure what they are doing in this arena and how to develop their diversity and inclusion activities, and also how to monitor success. I have all the references to this work if people are interested. Going to research, again, these are data from the UK. This is UKRI. This is a report that's been published recently, and yes, women are consistently underrepresented in EPSRC principal investigator applicants. Large grants usually are given to men and not to women. Constantly this difference is seen, and for large grants is really appalling. It's 5% women, 80% men, which is really not very satisfactory, I suppose. And of course, I mean, it's not just about gender. There is another report, again, and many data that I couldn't take because otherwise I wouldn't have finished in half an hour. I'm also looking my watch at the moment. Again, even the ethnic groups are also not very well represented. And essentially the people who get the grants or apply for the grants are white. So there is definitely something that white men, there is definitely something that we need to do about that. And indeed, the EPSRC is just running a survey at the moment. I just spoke to Zaf yesterday. She's in the energy sector, she's the champion of ED&I. I am the SAT of EPSRC, and we are really extremely interested in seeing how the community can really work together to make sure that all these imbalances are taken care of. So please, I mean, for the ones of you who are in the UK, please, can you do that survey, which actually finished, the deadline is 20th of August, and I heard yesterday that very, very few people have done the survey, which is, again, not good. Now, coming almost to the end of my talk, what else can we do in order really to make sure that we work towards an equitable development of technology and equitable development of renewable energies, for instance? Well, I think that we need a much more synergetic effort. We need to have diversity everywhere, on boards, for instance. We have to have diversity in decision-making positions. There are opportunities nowadays, and again, this comes from UKRI, where you have open fellowships. These are cross-disciplinary fellowships, where you can have a contribution from a social scientist and a contribution from engineers, or within the fellowship, the same person can spend 20–50% of their time just to create the positive culture change. And I think that we need also reskilling and training, and we need to be more transparent when we recruit and promote our colleagues. But more than anything else, I think that it has to happen upstream. We are looking only for the outcomes, but if we don't put the right input to that, I think that no algorithm can give us the good output if we don't have the right input within our program. And other things that come to my mind are mentoring, role models, higher connectivity, remote work. But here I want to be a little bit, I want to provoke a little bit the audience, and probably in a way, I want to pave the way for the panel, because these are for me dilemmas. I don't really think that all these bullet points are absolutely positive. Give you just a couple of examples. If I mentor somebody who is one generation younger than me, I might not be aware of what the real issues of that generations are. And it's a little bit like when I said, I'm a white person and I make an algorithm that recognize only white faces. So I think that, mentoring, you have to take mentoring carefully, and probably reverse mentoring is more important than mentoring itself. Role models. Have been for many years defined a role model myself, and I have role models to whom I look at myself, of course. But is that the right thing to do? I mean, everyone is different. Is it okay to emulate other people? I don't know. And again, and I could continue with connectivity, remote work, and remote work is extremely interesting, because I just read last week, remote work has put back women where they have always been, back home. So I think that, we have to be careful about everything we do. And again, my message here is really to look at it, with different eyes. And I think that for a change, I'm on time with my talk. And I would like to stop here. And I see that there are some questions probably, but should I start? I don't know. I can leave here. I don't know what you want to do, Jean.
Yes,
thank you. Thank you very much for all of you listening.
Thank you. Really a very insightful talk, Raffaella. We receive, I think, quite a lot of questions from the audience. I don't think we can take all of them, but some of the questions are quite related to the panel discussion later on. So I will move some of the questions to the panel discussion. So if we can quickly probably answer a number of them. One question I think is from a student. So what suggestion do you suggest as things students can do to champion the equality or diversity, since many of the times this change seems to happen from the top?
Well, I think that, again, students should be a little bit less shy and feedback everything that they believe, like the fact that, for instance, I didn't realize that my exam was unfair, to feed it back. But I think that you have to make sure also within the students themselves that they behave in a very equitable way. And imbalances start to start unconsciously just to happen, even when we create our design groups. And I think that one thing that I would like them to do is to feedback, but also to adopt what we should do always, to stop for a second and think about unconscious bias. We all have unconscious bias. And I think that if everything they do is unconscious bias, and promote, and I think promote also your colleagues that come from a different background, because, probably if somebody comes, I don't know, from a country in Africa, is alone in Edinburgh, might have problems. So try integration and try to feedback. I think that that's the best thing that I can say, I can advise.
Thank you, Raffaella. So maybe I can take the last question. For roles which champion the diversity, it is often people that lead these efforts are from this underrepresented area, which could be viewed as a diversity tax in terms of additional load. So how do we address these issues, get everyone involved, not like a punish people who champion positive change? I think that's really a good question, because yeah.
I wish I had the solution, but I think probably the more we be diverse, the less this problem will be there. However, you are absolutely right. Whoever you wrote this question this is spot on. for a long time, when I was the only woman professor of engineering at Heriot-Watt, I was sitting in all possible interviewing panel, even in areas that were not mine. And in many occasions, I felt absolutely stupid because I couldn't ask a very good question because I didn't know what they were talking about. And that's really bad. I think, people have more to do, but also in some occasions they look like stupid because they are doing things that they are not supposed to do. So I don't have an answer. I think that we should do things because we have to be there. But I think that the more we promote other people and the more give the opportunity to other people to do things in this arena. I think the easiest thing would be, if you are sitting on a panel because you are a woman, you are not doing this other job. So I think that even EDI jobs should be taken into consideration in the work allocation. And I look at Jean, who is a head of department, and I think that head of department should allocate time for other things which are not strictly speaking teaching or administration. So if you factor in also these other activities, at that point, the burden is not only on the people who are from a minority. So I think that it's the only thing that we can do at the moment.
Thank you very much, Raffaella. So for the course of time, probably we have to move to the panel discussion. But I did notice there's a large volume of unanswered questions. I will try to cover as many as possible during the panel discussion. So in today's panel discussion, we would like to focus at a slightly higher level to discuss the AI and energy systems, including the social dynamic or social benefit, how technology interacting with people, the just transition, and also the EDI aspect that Raffaella has covered in her talk. So I would also like to bring Dr. Nada Zamel to the panel on top of Raffaella and Markus as well. So Nada is a senior scientist at Fraunhofer Institute for Solar Energy System in Germany. Her research interests are focused on material development and cell characterization of PEM fuel cells. So she has been involved in many projects ranging from life cycle analysis to the investigation of effects of air and hydrogen contamination on fuel cells, to the analyzing on the effects of various stresses on the lifetime of PEM fuel cells, and etc. And beyond her scientific excellence, he's also an advocate for promoting the EDI in the scientific research community. So she's one of the guest editor of the special issue on the diversity and the inclusion on energy and the AI for our journal. So without further ado, may I invite Raffaella, Markus, and Nada probably to turn on your microphone and we can start with the questions. So to start with, maybe I have prepared some general questions, but of course I will monitor the Q&A and try to bring in questions from the audience as well. So if I can start with a very high level of general questions. I mean, AI has transformed the energy research, innovation, and practice in many, many ways. And in the next, and we are expecting many things, exciting things to happen in the next 10, 20 years. But if you can only name one most important aspect or one most likely breakthrough, which one would you see or would you say? So if we can start with Nada, Raffaella, and then Markus, if it's okay.
Okay, maybe I will be a little bit biased. And then, yeah, the way I see it, maybe from the perspective of electrochemical devices, I would like to, yeah, I would say that for AI, it would be very important for further material development, because if we really want to make any breakthroughs, for instance, in fuel cells or in electrolyzers, we really have to make the breakthrough in material development, because that's the key for reducing the cost and increasing their durability. We see this is happening now in batteries, and we have to try and translate this to fuel cells and electrolyzers. And if we keep doing the traditional thing that we do, go into the lab, characterize, and go back again, to the basics and do this iteration. Basically, it will take a lot of time, a lot of money, and we have to use something smarter, basically. And when we collect data, we need something to analyze this data in a smart way. So I would say, from my perspective, it would be material development, basically, for electrochemical devices or the future energy materials, if you will.
Thank you. Thank you, Nada. Raffaella, do you have anything to add?
Yeah, I mean, okay, from the technical point of view, again, I'm extremely biased. So what I really would like to see, I would like to see a really fully predictive model that can predict, for instance, anything which is linked to the energy, including the thermodynamics of the process, including everything which is in the process. And I have been always jealous of the fact that aeronautical engineers can design precisely an airplane which flies. And civil engineers can design a bridge that stands. We chemical engineers can design a process that works, but when it comes to the details, I still don't know why fluidized bed works, to be honest. It does work, but and prediction is much more difficult. But I think it's everything which has to do with incompressible flow, a compressible flow, that makes me really a little bit nervous. So I think that, yes, I will go there.
Thank you.
Not technical. I would like to see Markus' idea, the beautiful one for the decarbonization, with the human factor in it. Sorry, Markus. Probably that was your it was your what you wanted to see. I want to see your.
Shall I answer to this?
Yes, please.
Raffaella, hold your horses. So, and in fact, I could almost share the website. We are now looking at trying to, I told you earlier, we do this knowledge graph and we produce a world model. Okay, now the world is as it is, and you could now rate, you can look at the world model and can make statements about it. Okay, yeah, like you earlier looked at the gender ratio or something. But of course, there are 17 UN development goals, and they are broken down into targets, and these targets are quantitative, which basically means that you can you can look at this and you can calculate sort of the goodness of the world, and I'm almost tempted to share my screen if somebody lets me. May I do it?
Yes, please, Markus. Yes.
Oh yeah. Okay. You shouldn't have allowed me to do this. How to do this? Okay. I wish I knew how to do it. Who can share? All panelists? No. No. Yeah. Okay. Now it's working. Good. So what you see on my screen, okay, this is part of the Digital Twin UK, right? These are all the power stations. Can you see it?
Yeah.
And here you have coal and solar. And now you can sort of take your and development goals indicators, okay, and this is goal 9, and it's indicator 9.41. And you can now look at this power station and could say, okay, how good are they? And of course, these wind farms in the ocean are very, very good. But then you can, of course, look at coal biomass plant. Then that, of course, is not so good. Okay, so this is an example where we've been using the development goals, and hopefully we will publish something on this very soon. We're working, and Raffaella, you'd be very happy to hear this, okay? We're working with actually my friend who happens to be working at the UN in New York. This is, okay, so I was hoping to go to New York at some point, okay? Anyway, and she does some work on gender and inequality. So the beauty about the knowledge graph is that you can actually represent the whole anything, right? So we are now looking at some gender data from the UN and see how that correlates, for example, with other information we have in the knowledge graph to get a further insight on whether, for example, in a city, a certain way of laying out the city helps the girls, okay? For example, so I didn't know that, it never occurred to me, but when it's dark, women walk longer distances than men because they have to be more careful about where the streets are lit and so on. I was never aware of this. And then, of course, you know, that too could be seen as gender discrimination, and something simple like that could be, of course, part of the city planning. And here we go. You have then directly your diversity and your gender aspect represented. However, I also have a critical comment. I mean, yes, diversity is good, and we have now looked at two categories. Human can be male or female or some other to be specified version, but there are many more things. Okay, many more things. There are people who are from a certain country, people who have no hair. Okay, and then the question is, okay, so you can look at a human in so many different ways, and then the question is, do we really want in every community a uniform distribution over all features of the human? Is that what we want? And then if not, in what areas do we want it? And in what areas don't we want it? And why? Okay, so there are many open questions. And I enjoy when I do this knowledge graph work, the beauty about this work is I can think about these things and of course don't arrive at an answer, but maybe somebody in the audience can do that.
I don't think that we want, sorry, Jim, I don't think we want to include, we want really to look for everything, but we want to aim at being as much as diverse as we can. And you are absolutely right, Markus. It's diversity of everything. For me, at the end, it's only one diversity. It's diversity of ideas that permeate everything. That's all. But yeah, you're right.
Yes, that's really an interesting discussion. So that kind of relate to my second question is how technology interacting with people that now will introduce like ethical issues. So there's a very good documentary from Netflix about the coded bias. So I don't know if the panel members or audience have watched this documentary before. It basically invests the bias in the algorithm that after MIT Media Lab researcher uncovered flaws in facial recognition, for example, bias towards women or non-white, or people using like AI to screen to do the initial screening of CV when we apply for jobs, and again creating bias. So do you see like similar ethical issues in the energy and the AI field? Because when we deal with energy, we are not directly dealing with people, but it's essentially any technologies or energy that we develop will benefit the society and will benefit the people. So do you see like there's a probably less serious or like new ethical issues in the specific energy and the AI field? If yes, how can we solve this issue? So this time probably we start from Raffaella and then Markus and
Jean, I think that this is absolutely spot on. And I think that there is a bias also in the energy arena. And it's when we look at solutions for the energy transition. Because all what we do, we look it from our point of view. And we assume that everyone in the world can have access to renewables, that everyone in the world can have access, can afford to pay for energy that can be probably cleaner, but also much more costly. And there is an ethical issue there, as there is an ethical issue in the fact that in the first place, we are developed countries because we have used oil and gas, and we have polluted because we have used oil and gas. And now we should be aware that we want to stop the development of the developing countries when probably in the developing countries access to cleaner and cleaner energy and more expensive energy is not readily available. So I'm not saying what is the solution, because there is no solution, but I'm saying that yes, there is a bias there when we look at decarbonization only from our side. It's exactly the same like looking at algorithms that recognize only white people. It's exactly the same.
Yes, indeed. Markus, would you want to add anything here?
Also, is there confirmation bias in machine learning in other areas than when it in energy, in the energy realm? Absolutely, because now if you look at the machine learning algorithms you've used for your work, okay, this is of course based on the experiments you conducted, okay, and if you look into the process parameter space, it's just the one tiny little part in an enormous space, and whether or not this is actually representative for the effects you want to study is completely unclear, okay. You may do a sensitivity analysis around this trajectory, and that gives you some idea, but whether you're in the whole, whether you cover the whole thing, and whether the machine learning is effective, you never know. I mean, like, this is just, is there confirmation bias in machine learning? My answer is always, must be. No, there's no escape from it. Has that ethical implication? I mean, like Raffaella said something, I'm sure it can have. It's not entirely obvious that, like, if you just look at machine learning and AI and specific technology, how that translates to people's behavior. It may well do, but if you ask me for a specific example, I wouldn't be able to give you one.
Mm-hmm. So Markus, I really like your work on, for example, the parallel world scenario analysis. Do you think it can help, for example, in solving some of the just transition issues, like to include the social dynamics, to include the non-technical barriers, implication on the environment, on the society, into this scenario analysis, and to help solving the barriers in the coding or in the algorithm or in the development of any new technologies?
I mean, to be honest, yes, I would love to do that. Okay, there are two problems with it. I mean, like, the first and most important problem: the moment you do something with people, research gets complicated. Okay, because you have to have all these ethical assessments. You have to be careful with the data. You have to anonymize it. You have to make it aggregate. It's really hard. Okay, and people are not molecules in the lab or particles, so you've got to be a bit more considerate, okay, with somebody than a particle. The particle doesn't, I hope, not care too much if we measure it and report the position of the particle, whereas a person may not think that way, okay. And so Google has all this information. Yeah, Google has a lot of answers ready in their pocket. If we could analyze Google data, we could give answers to a lot of very important questions. Unfortunately, we cannot do that. But will I try? Will we try? Okay, absolutely, we want to, yeah. But we have to try it in a way, and this is where this whole ethical thing comes in, not just in the outcome, but also in the way we do things.
Exactly.
Okay, that's the key point.
Exactly. Fully agree. Thank you, Markus. So Nada, do you have anything to add on this topic?
No, for me, I would agree with Raffaella and Markus. At the end of the day, it's whatever data you feed the algorithm. And if there's a bias, of course, it will carry through. And I could see that this would happen because as a developed world, maybe we would be concentrating on whatever works for us, but not necessarily for whatever works for everyone else. So I completely agree with Raffaella and Markus on this. Yeah.
Yep. Good. Thank you. So I want to take questions from the audience. So I see, Raffaella, you're already typing the answers, but we can take this question live.
Sorry, I was typing some answers because there are some very, very interesting questions, and I didn't want, and I had some data that I want to share with specifically with one person that was interested in data for Africa. So I had the data, so that's why I wanted to.
Okay, so let's take that question. Let me see. I see. It seems I lost that question.
Probably I replied. Sorry.
Yeah. Okay. So let me just find. So I think it's about the pandemic. So we are now in the pandemic. This has been the overwhelming importance. We're talking about the green recovery. We want it back to normal, but to the new normal. So how can we incorporate all these things that you mentioned in your presentation on the sustainability, better energy, but also a better EDI in the community, and how can we embed these in the green recovery, and we are not trying to lose the priority with the other more important priorities. I think this question is mainly for Raffaella, but also I think Markus and Nada can add on can add on your views after Raffaella, if that's fine.
Should I? Well, I think I answer very unsatisfactory to that question. I believe that I don't like to think about the new reality. I like to think that we have an opportunity here. We have an opportunity to start with something that we have learned and to rebuild something which is probably better for all of us. And at the base of that is the fact that you have to be like more inclusive. And then I think that it's time now where everybody has had this is unfair. I shouldn't say everybody has had the opportunity to be online, because that's another inequality. Not everybody has access to free and fast internet like we do. But definitely the pool of people that can contribute is larger now. And I think that we have to make sure that all the parts of the society take care in contributing to the rebuilding of the society. But I think that the only thing that we can do is just getting involved. I mean, I don't see any other way but not to start by getting more involved ourselves. And I think that there are things that are happening at the government side, but remember, they are just policies, they are just laws, but it's not enough to comply with the laws. So I think that we should take the laws and the policies and adapt and make them really live and work for what we want, to be honest. So I don't have any other suggestion.
Thank you, Raffaella. Nada or Markus, do you have anything to add on this question?
For me, the way I see the pandemic, actually, there are some positives to it from this perspective, because I think before the pandemic, everyone was going about their lives, and whether it was a man and woman in the relationship, they were going about their lives, dropping off their children at daycare or school, and so on and so forth. But now they found themselves in the home together. So there was, in certain cases, of course, in certain cases you had some problems, but in a lot of cases, I see it from my personal circle, we see that now the men realize really how much that the women were putting in, because a lot of the women that I knew and myself, we were all part-time because now we have to take care of the children as well as take care of our jobs. But suddenly now our partners are in there with us on a daily basis, and they saw how much work it really is. So you see that there is a lot of improvement from that perspective. So the pandemic was not all negative, but in reality, in some cases, some relationships were maybe on the brink of collapse, but now you see that the man is more involved and they understand, okay, what's happening. And you see that there's discussions within the workplace that didn't happen before. So again, I'm being biased. We're talking about the Western countries maybe, but also in the Western countries, this inequality was actually there and it still is. And I find that, okay, there's this conversation that is happening. You have more, like for me, myself, like I'm talking from a personal perspective, I am now more confident in the fact to say, okay, no, stop. I'm also a mother, but I also like my job. And this is what needs to happen. So I'm now more confident in saying this is what I need for my work-life balance. And before the pandemic, I was actually a little bit shy about it, just to really demand what needs to be done even by my employer. So you see a lot of confidence that is happening at the moment, and we need to share this. We need, as women as well, to share this among ourselves, each other, and not to be ashamed of being a mother, of being a working mother, because there is that shame towards it, that you're leaving your child in daycare, but there is no shame in it. There is no shame for caring for your child. There is no shame for loving your family and taking care of it. So this conversation needs to happen, and like Raffaella said, we all need to get involved, and everyone has to get involved in however way they can. So even if it's just talking to your friends about it and having this, some community around you that helps you out as well. And there is no shame in needing time for yourself.
Thank you, Natalie. So Markus, do you want to do a quick summary on this, or you're fine with that?
Quick summary on this, that's interesting. What did COVID did to me? The good thing is I established a gin and tonic routine every day. Okay, this is how I reacted to COVID. Was there an advantage? I guess, of course, yes, there must have been. Nevertheless, I'll be very happy when I can see you all in person very soon, hopefully. So that we can have this type of conversation with a gin and tonic, hopefully. And yeah, I mean, like in terms of work together with my students, I mean, given that I always work with people that sit both in Germany, in England, and in Singapore, having Zoom conversations was not new as such. But if you want to be creative, not a good idea. Yeah. So anyway, this is what I have to say to COVID and energy. And I mean, like one thing, the digitalization definitely got a good push. This is good for us. AI and energy will benefit from the improved infrastructure for COVID. That's a good thing. There are so many big projects now on G5 mobile networks. I think this is also going to have enormous impact. There was one question about material research, and that one person said, yeah, okay, we publish in these papers new catalysts, but then nothing scales. Okay, this is a maybe indirect sort of confirmation bias. Okay, if you look at our quality assessment criteria in science, which is number of citations and papers published and things like that, okay, you will see that in material science, you get enormous numbers and enormous citations, okay. But then if you look in the engineering level, okay, people who actually do the higher TIL levels, okay, they don't get as much attention, although this is where the problems lie, okay. But of course it needs to be connected. My answer, like the answer to anything I'm asked, is of course knowledge graph. Yeah, you won't be surprised. But this is certainly, you know, how do we push technologies like these fuel cells further? How do we do this? Maybe we can benefit from the better and faster access of academic findings through maybe intelligent agents that go through these papers, and there are plenty of publications. So I guess this is one aspect that we will see where AI and energy will sort of be, you know, the virtuous circle where one thing improves and the other gets even better, right? And so this is what I could personally see. We in CARES, we work together with my colleague Alexei on creating a chemistry robot. Okay, Nada, you first said, okay, we need to get away from, you know, one person doing an experiment, and then, you know, can we accelerate this? And of course, if you have the full laboratory and the knowledge graph, of course you can accelerate it. The researcher then turns into will be absorbed into the cloud, so to say, and there will be an agent that does all that. And I see this coming in the next 10 years. We will have many automated laboratories, also for, you know, in particular for different materials, membranes, coatings, catalysts. This is where I see a big impact gonna happen.
Thank you very much, Markus. Really, really insightful. So I think for the course of time, we have to close the panel here, although I have tons of questions to ask, but probably we were not allowed because of the time. So thank you very much, Raffaella, Markus, and Nada for the presentation and for the panel discussions. So now I will hand over to Dr. Billy Wu, who is the conference chair, to announce the best presentations of the conference, the exciting part, and also to make a conclusive remark. Billy.
Great, thanks, Jin. And just to echo what you just said, I just want to thank all the speakers, all of the contributors, and all of the helpers who really made the second International Conference on Energy and AI a real success. In particular, Xuan from Loughborough, obviously a real driving force, Qiu Zhao from Tianjin University, and his researcher, Wei Du Zhao. He's obviously been a key driver there, and also Huizhe Wang. Without those people, it would have been a real effort, and obviously all the researchers as well. So we've looked through the various contributions for the conference, and we've been impressed by all of the contributions, but a few of them really stood out for us. So on behalf of the Energy and AI panel, we wanted to award a few prizes for various talks. So I've got the list up here. So first of all, from Argonne National Labs, we've got, and apologies if I pronounced the names wrong, Oyepola Owayili, on his work on flame modeling of spray flames with mixture of expert-based learning of combustion manifolds. We also have Daniela Ruiz from UC Irvine for her work on maximum efficiency operation identified by machine learning for PEM fuel cells. Then we have Yangqiu Xing from Tianjin University for her work on selection of optimal sensors for fault diagnostics of PEM fuel cells based on data-driven methods. We also have Xinji Zhu from Lund University for his work on automatic generation of the reaction process variable and novel approach based on the artificial neural network. Kai Wang from FAW, so industrial perspective on PEM fuel cell degradation by long short-term memory networks. And finally, we have Paige Wenbin Chen from Nottingham University for her work on scenario-based analysis of a deep learning occupancy and window recognition approach for energy efficiency. So thank you very much for all of those contributing authors. We have a certificate that we're going to share for all of those contributing authors. So if you want to but also we invite all of those authors for a full paper in the Journal of Energy and AI, which I believe will come with a APC waiver, so article publishing cost waiver. So hopefully we will see your exciting work expanded and featured in the journal. But beyond that, again, just to kind of share my thoughts of the event, I think it's been fantastic to get all the contributions from people around the world. We've tried something different with this kind of in combination of live talks with pre-recorded talks as well. So the talks are going to be up for afterwards for prosperity. So please do go check those out if you haven't done. And also we hope to continue the energy and AI conferences into the future. Hopefully in the future, this might be an in-person event. But again, I just wanted to thank the audience as well for your engagement. And I don't know if Jin wants to say any final words or if that's okay.
Yeah, absolutely. That's fine for me. Thank you very much, Billy, for all your efforts you have made to make the conference so successful. Thank you.
Right. Well, thank you very much, everyone. And with this, I guess we are closing the second international conference on energy and AI. Have a nice day wherever you are.
Thank you.
Bye.
Bye, everyone.
Bye.